Well, hello everyone and welcome. Today's topic, why enterprise AI coding agents need more than a better model. I'm Caleb Kinchlow and I'll be your host for today's session. Now, before we get started, just a quick bit of housekeeping. Today's session is being recorded and we'll send the on-demand recording after the event. And if you have any questions during the presentation, please submit them using the Q&A panel and we'll address as many as we can during the Q&A portion at the end. All right, so let's dive in. AI coding agents have quickly become part of the modern development workflow, helping teams move faster and increase productivity. But as organizations look to deploy these tools across larger, complex code bases, many are discovering that the success depends more than the model performance alone. So today we'll look at what it takes to make an AI coding agent effective at an enterprise scale. Now, I'm pleased to introduce our guest speakers. Joining us is Brian Friedman, Director of Technical Marketing at Modern. He helps organizations understand and adopt large-scale code modernization and transformation strategies. And of course, also joining him is Patrick Vaughn, Director of Product Management at Modern. Patrick focuses on building solutions that help engineering teams manage and improve software at enterprise scale. Brian, Patrick, thanks for being with us. And with that, I'll turn it over to you.
Sounds good. Excited to have everybody today. I think one of the big things looking into Modern was I spent most of my career thinking about how agents and humans can work together, but now at Modern, it's seeing how we can even change the workflow of agents themselves. Brian, anything to say before we get kicked off?
No, I'm excited to show you guys some really cool stuff today. So Patrick, take it away.
All right. So first, what we'll do is we'll quickly lay out the land and see what we're going to cover today. I think, especially thinking about how agents work and go through essentially how they can go and execute, we'll take a look at quickly this context problem, and then we'll see what happens when we leverage a tool and equip this agent with it called Prethink. We'll go through some live demos, and then we'll also go through some code quality metrics. And then we'll wrap it up, and we'll answer any other questions. All right, so I think before we start, agents have transformed so much from like inline code completion all the way down to like agentic execution. Maybe we'll start with a poll. If everyone wants to go click on the button poll and see what type of coding agent they leverage, and then we can keep going from there. All right. Awesome. So I'm starting to see some answers come in. And as I expected, it's little all over. So people use Claude Code, they use other pieces. And then I think the big thing within this is they're all great at like clean, isolated projects. But when you start leveraging some of these coding agents in enterprise code bases, for example, ones that are like multi-repo or are governed by years of different like standards, something might break. And when we think about it, we need to start to think about like the quality of the output, and that these coding agents are amazing. It's just they're non-deterministic by nature. And then more recently, we need to start to think about like the economics of this token consumption. I think the fix there isn't a better model, but it's essentially providing the model and the agent some context deterministically. And imagine, is this possible where we can provide this even before the session even begins? So starting with the problem, and the problem isn't, again, the agent's intelligence. It's that the agent has no memory of the code base every time it starts a new session. And we're rebuilding this memory every single time. And especially in this token economics market, it could get a little bit expensive. So this is how I like to think about it. So the core issue, again, every session starts over and it begins every single time. So the agent wakes up and it's almost like every day is Groundhog Day with every task. So it's rediscovering the code base from scratch and the same architecture, the same dependencies, the same conventions it figured out an hour ago, needs to be redone and recarried over. And it's because that discovery is non-deterministic. So the same questions, different exploration paths, sometimes even the wrong direction entirely. So imagine if we had two engineers asking the agents identical things, they would go through two different journeys to get to the same answer. And it would also be two different costs because, again, it's a little bit unpredictable to see where the agent goes to try and get you these answers. So, how do we help the agents optimize this rediscovery piece? What we see is usually the model will start to grep, read, and parse through the last session, and these old search results will start to pile on top in this context window. If we look at some of the stats that we have here as an agent goes through some of it, is that 60% of the tokens are spent in the discovery and understanding phase. And the second bit of it is you can see the signal to noise ratio, where at the end of it, it's only a portion of the actual output being leveraged by the agent versus it just bouncing around and trying to find the right info. So I think the best way to look at it is let's go look at what the agent actually goes through an agentic loop. So step one, it's needs to go and discover and understand the code base. I think one of the pieces is that, again, it is non-deterministic, even the way it searches. So it's going to try to read .md files. It's going to start to go and look at different areas. But again, these .md files currently don't provide like a brief or a roadmap. So it's just taking in context and trying to figure that out. And let's say the input is okay and it starts to build a plan. And then when the human looks at the plan, it realizes it's still missing some context. It will then redo that loop. Okay, let's say you get through discovery, understand, and plan, and now it starts to act. Even at that acting phase, it's executing on the plan, but again, non-deterministically. So it's trying to find the most efficient way to go about it. And then even when we come to review and validate stage. So imagine in this loop, it might have to do a few iterations, and it's because it's missing this blueprint to go through each of these phases one by one. So how do agents today try to collect some context? What we found is it's essentially three different ways, and each of these three ways don't get us exactly where we want to get to. So for example, one, which is file scanning, it's reading the files, following the references, and this could cost quite a few tokens because it's repeating it every single session, and it's still just trying to pull together some conclusions. Next, what it does is it can look at documentation like READMEs, wikis, or code comments. And the problem with that is there's a human element where we need to keep all of those pieces also up to date because it's good input versus good output. And then finally, there's this context retrieval component of it, where the agent is starting to leverage different tools like RAG, MCPs, and they're trying to pull different pieces to try to answer each of these questions. I think the common theme within all three of these is that they're all approximate understanding. It's using more tokens, spending more time, and what we really want to get to is how do we turn some of this deterministic so that it's an action that the agent can follow every single time versus giving it a bunch of stuff to do research on. And again, it will take different paths, just like if you set off 3 or 4 different agents to go get this context part, it wouldn't follow a linear line. The funny thing is the knowledge that the agent needs is already technically in the code base. The only component of it is that right now the agent doesn't have an easy way to see and use this and also pull these relationships together. And some of these are like dependency relationships, security conventions, org standards, and architectural boundaries. What we want to do is imagine if we could take all of this, that the agent needs to go essentially discover through, structure it for the agent, and then also provide it right alongside the code. And that's essentially what our starting to do for our thinking of pre-think. So let's do another quick poll here, which is how would you describe your organization's current stage with these AI coding tools? Would you say we're starting to leverage it like in the day-to-day? Are we seeing like other pieces of it? I'll let people answer a little bit and then we'll keep going through. And the reason why we say that is, or we want to see where people are with this is, we want to see how humans are able to right now provide the right context for these agents, but we want to bridge it a little bit more. Awesome. So I'm starting to see some of these responses. As I see again, a wide range. Awesome. And I think that's the thing with some of this stuff is right now these agents, they're essentially interacting directly with the code. How do we provide it some of the context that we're able to have, almost like treating it as a teammate? And with a teammate, it's essentially onboarding like an AI teammate. So what are the pieces that we need to leverage so it gets that info? All right. Let's move forward. Okay, so now, like I alluded to, if we were able to provide some of that context, it's something that Modern wants to do, and it's in the way of what we call pre-think. But before we go into pre-think, we first need to look at some of the fundamentals of how we make pre-think even possible. Okay, so I think starting at the bottom, your code base, it's the raw source files. What we do there is we're able to take that foundation of your code base and then start to parse it into this thing called a lossless semantic tree. Think about that as what the compiler is able to see. Structured data with types and relationships already resolves so that the agents can read it and look at it as almost a source of truth. And right now we're working across quite a few of the languages like Java, Python, C#, Go, and more. Okay, so now that we have that LST, what we can do on top of that LST is essentially build a bridge so that these agents can actually action it. And this is what we call recipes. So they're programs, not prompt files, which means these agents, when they go and try to action a task, they can go and look for a recipe which is deterministic so that essentially you get the same input and the same output every single time. And because it's programs, not prompt files, you're able to test these recipes just like you're testing code. So you guarantee you get that high quality output that we want an agent to ever use. So again, let's tie this back quickly to pre-think. So pre-think is actually right now used as a recipe in its foundation. We take the LST, so we're preventing any LLM or guessing, and we essentially grab all this great detail out from it, and we provide it as a brief. So almost zero tokens, and they get all this context, and it essentially allows the agent to start looking at the different layers right away and jump to those relationships. So we were essentially thinking about this question when developing pre-think, and we were thinking, how do we provide context without the agent is searching for it? And again, like what I just talked about, having the lossless semantic tree, how do we pull that and build a blueprint for our agents to go through it? Then we were thinking, where can we put this in the process? And in our mind, it's how do you shift it left as far as possible, because it's built off the LST. It's something that the human can do instead of the agent, and provide it to the agent. So essentially they have a deterministic blueprint up front with full context without even spending one token. So let's dive deeper into this pre-think component. Okay, so I think about it as a clear machine readable picture of how your code actually works. And what we do is, again, we derive this by running these deterministic recipes over this lossless semantic tree. And these lossless semantic trees are built at every single repo. And this prefink recipe essentially provides this .md that your agent can get that tells them about the dependencies, about the conventions, about the architecture. And then essentially the agent reads those facts instead of trying to find them all out and using tokens on the fly. So essentially, what you see here is it's a way to feed context to the agent before any of this process even begins. It's not RAG because it's not pulling snippets and using token heavy search. We're not embedding it because it essentially is deterministic and it's not probabilistic vectors. And then finally, it's not prompt engineering where we're actually providing the actual code blueprint for this agent. And again, prefink essentially analyzes that LST of that code model and provides all this rich context that the compiler is able to see so that the agent can get all of this. Okay, so let's look at some of the elements that prefink can actually go and pull. Essentially, it's 6 types of different kinds of knowledge, from service APIs to dependencies to test coverage to security config, conventions, and also different architecture. And the good part about it is prefink can actually also be customized to your own organization, and this is like the context that we're able to go and provide. And right now for prefink, these are all the different languages that we support out of the box so that it can be leveraged for your agent and your code base. All right, Brian, do you want to show everyone how we can start to leverage some of these prefink context recipes so that agents can essentially start building this context deterministically and efficiently?
I would love to, Patrick. Yeah, thanks. So I wanted to start with looking at the actual platform. As Patrick talked about, the LST and the recipes. And so we're going to take a look at how prefink works with the agent, but I think it's a good to sort of contextualize for you all what it's building, how it works, and sort of like what the recipe is actually doing. So I'm starting in the platform here. This is the Modern platform. We've got a set of organizations, which is really just a grouping of repositories. The repository in this case, we just have one. I'm using an open source project called Shopizer. It's just a large mono repo e-commerce application. So we're just going to use one in this case, but you could run this recipe against your entire organization, your entire set of all of the repositories or whichever repositories you want within your organization. For this example, we're just going to look at one for the moment. And this is the recipe here that updates prefink. So you can see it's a whole list of things that it's gathering, and we saw the slide earlier of sort of what it collects, but it multiple languages, multiple frameworks. It's just sort of an endless list of information about the code. And then also you're able to set, it doesn't matter what agent you're using this with, whether it's Claude Code or Copilot or whatever it may be, you can set the config file that you want so that the agent knows that the prefink context is there. So it'll actually write that information to the config file as well and say, hey, when you do code exploration, you've got all this great information you should use first. So if we run this, we could run this, which I already have one run, so we'll just not have to wait for it. But this was run against just this one repository. And again, you could run it against as many as you'd like, but you can see just against this one repository, we've got all these new additional files in the repository. And as Patrick said, the idea is let's get this information as close to the code as possible, as close to where the agent is already looking as possible. So let's commit it right alongside. We can talk about some other options, but that's how it works by default. And you can see it's writing both Markdown files and CSV files. Those are both formats that agents love to read and generate, in fact. And so the Markdown file for every CSV file sort of gives it an explanation, tells the agent like, this is what you can use this for. These are what the various columns are. And then the CSV file itself with that information. And you can see we've got coding conventions, error handling, exception handlers. There's a lot of code quality metrics, which we're going to take a closer look at later. Test gaps. There's the architecture. This is a architecture form, JSON format of architecture, and all this great information. And then here's the config file that we were talking about, where it says sort of lets your agent know that all this information is there. So this is a recipe that runs and gets all these results, and now it's checked in next to, we could, if we were in the platform, we could actually check this in here and commit all this code across as many repositories as we'd like. And then if we wanted this to say run on a some sort of cadence or as part of a CI, part of the CI pipeline, then you can keep the code, you can keep the context up to date right next to the code as it changes. Okay, so now that we kind of understand what Prethink is and what it's producing, let's take a look at how it works with agents. So I've got a few different agent sessions here that I've already pre-run so that we don't have to sit there and watch it think through a whole bunch of stuff. So we're just going to kind of walk through each one. I've got basically two. So I've got that same ShopAdvisor repository checked out over here. It's just that same open source repository, but I've got it checked out twice. I've got it checked out once in a with Prethink folder and once in a no Prethink folder. So you can see in here we have this context, all the context files, and they're all checked out, or they're all committed to the repository. And then here is just the repo with no, nothing else is checked out. So we're going to kind of take a look at how the agent handles both of these scenarios. So I use Claude Code here. You could, again, use Copilot, use whatever agent you want. This is just the one I've got access to kind of walk you through. You can see I started with just sort of a basic question that a developer might ask as they're exploring their code. Maybe they need to make some changes to something as part of a feature request. And they just want to explore what the blast radius might be of changing a particular class. So in this case, I'm asking, what will break if I change the order entity? And you can see right off the bat, it says it's going to check the modern Prethink context files. That's because it knows from the claude.md file that the recipe added information to, that it has this information to look at, and it's starting to take a look at that. You'll also notice that it's actually querying the data. It's not just reading the CSV, because if the CSV is thousands of lines, which it potentially could be, then you're wasting context on a bunch of information that you may not need. So it actually has been instructed, knows that it can. And that's one of the nice things about CSV files is they can be queried just like a SQL file, a SQL database, basically. So it's querying and only getting just the rows that it needs for the question that was asked. So it's going to look for stuff specific to, order, that's around the order entity. So you can see it's seeing, now let me find what's finding order. It's doing all these queries, and it's referencing quite a few of the CSV files that it knows about. And then it continues on, and eventually it spits out, hey, based on this context, here's all this great information, what the order is, all these test files. It's got all this great stuff, tests that need updating, service business layer, all this great stuff. And then it even sort of summarizes, hey, here's what you should do. And this whole thing took about a minute for it to kind of do all those queries and come up with the information. Now, if we look at the session that does not have Prethink, so this again is in the running in the no Prethink folder. Same question, but here it's saying it's going to explore the code base, which is, as Patrick was talking about, that's part of the agent loop. It's the default. It's going to do, find. It's going to do a grep and read, and that's what this sub agent that it launched essentially is doing. And you can see it uses a tool 39 times, so it's grepping, reading, grepping, reading. And then it's using, tens of thousands of tokens here. You can see 56,000 tokens. It's claiming that it used on that sub agent. We're going to look at the a more specific number in just a little bit, but that alone, just to explore, took over 2 minutes. So twice the time that we already had to answer back with Prethink. Here, it hasn't even figured it out yet. Now it's finally explored it. It finally is spitting out the same, basically similar information that we saw. Little something about the dependencies, but again, here it's the information is perhaps not even as detailed as the Prethink information was, because it doesn't know everywhere to look. It's just kind of inferring where it needs to look, as opposed to getting every occurrence of something that might be there. So one thing we can do is, I've got a script here that basically parses the transcript files of Claude sessions and sort of spits out the token usage. So I thought we could just kind of take a look at how many tokens each one of these is using. So if we start with this session here, and we do sort of the no Prethink, and again, this has no context on this one. If we were to start with that one, we can see it's using over 2 million tokens, right? A lot of those were cache reads, but even so, it's using tens of thousands of output tokens. And again, most of it was from that sub agent that we saw running. Now, if we do the same kind of a check on the with Prethink session, we will see how many tokens that used. And in that case, it's quite a bit fewer, right? So it's still hundreds of thousands of tokens. It's still reading information, and it's using context, but that's like 25%, something like that, of the amount of tokens used. So quite a big difference, and it's not having to use call that extra sub agent. So it's doing more of the reading just within the session itself. So that is sort of showing how Prethink works, how the recipe pulls all the context, shows the tokens. So it's the tokens, it's the time, it's the the level of detail that it's able to get from Prethink, as we kind of saw there. One of the things also that I think is important to realize is, we saw the recipe in the platform, we saw all the things that Prethink is doing, all the things that it's running. But what about a case where maybe in your organization you have specific conventions or something else that you need to look at, more information about the code that might be specific to your organization, or conventions that you're using within a particular team or a business unit that you want the agent to also know about? Because a lot of times the agent is guessing at that. It's looking at the code and saying, okay, I see that they're doing this here. Maybe that's what they want me to do all the time. That may or may not be the case. So you can actually use Prethink to do that kind of stuff as well. Remember, Prethink is just a recipe. It's an open rewrite recipe, like Patrick was talking about, and like we saw on the platform. So it can be customized, and you can remove things from it if they're not relevant, you don't care about them, or you can add things as well to them as well. So we're going to take a look sort of at what a custom Prethink recipe might look like too. Sorry. So I've got another repository here that is a sort of a smaller scale e-commerce application that I've written just to kind of show a couple of key examples of a specific case. And I've got a custom Prethink recipe that I have defined here. And there's nothing super complicated within a recipe, or at least within a YAML declarative recipe. So, we'll just take a quick look at it. It's basically, in our organization, let's say that we have sort of a few different conventions that we use within our team. One of which is that we want to always put rate limited and rate limited annotations on, say, public API endpoints. We want to put auditable annotations on, say, endpoints that writing to our database. And we also maybe have like a specific wrapper class that we want, or a base class, I should say, that we want for all service-to-service communication. So any service clients that you're using, you'd want to extend from that. So those are common things that you might find in a development organization, maybe similar to what some of you guys are using within yours. So we start with just by including the base level Prethink starter recipe. This is the one we looked at in the platform. And then we're adding 2 additional data tables that we're exporting along with the base level ones. And in this case, we're just running some basic search recipes, some basic existing open rewrite search recipes to find these specific annotations and spit those out into the table. And then we're giving some description of what those mean, what those are. And then it's exporting the table with all the occurrences where those appear in the code, so it can go look at them and reference them specifically instead of having to read a whole file or multiple files. And the same thing here with service client. We're just using a basic find types recipe to go find where that's being used in the code everywhere, and then exporting that out to a data table as well. So I've already installed this recipe and I've run it against this repository. So you can see here, it's spit out all the same files that we are used to seeing, but it's also now got the additional tables and also the markdown files that go along with them. So those ones were not sort of the base level. So we've got that new information there. So now let's look at an example where we might, instead of just asking the agent to find information and tell us information, maybe we want the agent to actually now go write some code, but follow these conventions that we expect it to follow these conventions that we have within the organization. So in this case, in this session, I sort of said, hey, let's add a new endpoint about loyalty rewards points redemption, and so that's a thing you might want to add to an e-commerce application. So again, it's going to look at the modern prethink files based on the instructions that it knows about. And right off the bat, you can see that the prethink context establishes 2 hard constraints. It knows right away, hey, I need to extend all service clients from this service client base class, and I need to add these annotations when it's appropriate. So it's now, once it understands the context from this, it's now reading the specific CSV. So it's going in, looking and saying, okay, where is service client being used? Let me go see how it's being used in these files. Instead of going to read the whole file and grepping for service client and reading and figuring out where the context is, it knows right where it is from these queries, and it can then go look at that and modify it, and copy it, I should say, when it's modifying the code. And so you can see it says the patterns are clear. It understands what it needs to do. It's going to read just what it needs to read based on what it knows. It's got the full pattern, and then it starts to write some code and add classes and all of this stuff. And we've got it, it's even checking the context again before it does more work. And then here you can see it says what I added, a new endpoint to redeem customers' loyalty points. And it's added 2 files. It's added the rate limited auditable. We can actually go look. These are some of the files that it added. So here it's adding the, this one is extending the service client. And then this one, it's adding the auditable, the rate limited. It's adding the rate limited annotation there. So you can see it followed those rules. It knew to do it. It's even flagging sort of some questions that it might want the human to come in for to provide some judgment on, and all of that only took a few minutes, and it was able to sort of follow what we expected. So yes, this took probably only a few minutes and potentially fewer tokens than if it had to go investigate this. But more importantly, it did it. We know it was more reliably able to come to discover these patterns and sort of copy them. All right, so that is the first part of the demo. Let's switch back to the deck really quickly. And I'm just going to talk a little bit about some code quality stuff. We saw earlier in the platform that there were some code quality metrics that are coming out of the prethink context as well. So before we do that, let's just start with this kind of another poll question around sort of the biggest challenges your team faces. I think a lot of teams are learning how to use AI and how to roll it out and how to, give it the best context and all that kind of stuff. So, it'd be interesting to see what you all think are the biggest challenges that your organization is working through. All right. So while you guys are answering that, I'm going to continue on with these slides. So here, the point here is that agents need, humans know about the code quality kind of things. Humans are going to basically bring judgment with them. They're going to be able to look at code and say, this is very complex. I don't want to add more code here. They're going to be able to say, whether or not this is a particularly good architectural decision based on what they know about code quality. Agents may or may not do that. Typically, agents just like to write code and make it work and make the test pass, in the most efficient way possible. And sometimes that just means adding a bunch of code, adding more and more code, or adding, code to a class. One of the things, one of the quality metrics we'll look at in a moment is, the God class metric, which basically is sort of a measure of how complex is this class, how critical is this class to the code. Is, if it's doing too much and it's too much is running through it, then it becomes, the code becomes much more brittle, and there's more risk involved in editing that class or adding things to that object. So pre-think is basically putting all of these quality metrics in a place, just like the rest of the context, in a place where the agent can access it and make decisions based upon it, just the way that a human would based on their knowledge of code quality. So what are some of the things that we are capturing? Sorry, I was a slide behind there. Okay, so one of the things we're capturing is metrics across methods across classes, packages. We even are capturing, or pre-think is capturing things like test gaps, test coverage, code smells, all of that stuff across multiple levels, method, class, package. So, these are typical code quality metrics that any sort of code quality scanning tool would discover. We're just pulling it out of that LST and putting it into context files that pre-think generates so that the agent has access to them. What we're going to look at in just a second is a few quality visualizations as well. The nice thing about pre-think exporting data tables as CSV files, the agent is able to read those CSV files, and that's great. It can read the text and make sense of them. But as humans, we prefer, some sort of visualizations and graphs and charts, but we can build those based off of the CSVs as well. So not only does the pre-think code quality data give access to our agents to see this stuff, it's actually now also enabling humans to kind of look at it as well across the organization. So let's jump back to our demo one more time so we can look at a couple things. So if we go back to the platform first, let's start with those visualizations I was talking about. So within the platform, any recipe that runs that might produce or that produces data tables also may allow for visualizations. So if you click on the visualizations, you're going to see a whole bunch of possible visualizations here, excuse me, about portfolio code health, quality metrics. We'll take a look at some of these. So these are just all the code quality metrics that are coming out. These are just some visualizations that you can run based on those. I've run a few so we can look. I'm not going to look at all of these, but just to give you a sense of the kind of stuff that you can see. Maybe this is an example of something run across an entire organization of repositories instead of just that one ShopAdvisor repo. So this is a whole bunch of open source repos sort of collected together. And this is like an executive dashboard that you might want to look at regularly to see like what's the trend, how is our code quality trending. And then this is a handy one as well, something like a technical debt hotspot. You can see which methods are maybe overloaded with complexity and might be ripe for a refactor, and also something that an agent would look at and say, maybe we should add more to that. Or things like comparing code complexity against test coverage, right? Where do we have gaps? The most complex code with the fewest tests, right? That might not be a great combination. So those are just some of the visualizations that are available. There's a lot of visualizations available. These are just some of the ones we're looking at. From an agent perspective, let's come back over to the code. We're going to use the same sample e-commerce platform or same e-commerce example code to show sort of a use case of code quality. You can see I'm running my own little query here to look in the CSV files and just see that, where in this code do we maybe have a God class that we would want to be careful about, touching or adding more complexity to. So here you can see the order service class has high severity, and these numbers basically equate to God class, lots of complexity. So we want to be careful if we were a developer to what we do with this particular class. As an agent, I might not know that just from looking at the code, just reading the code regularly. But if I have this context, then as an agent, I'm going to be able to make better decisions. So let's see what happens in a case where I, specifically say, let's add logic to the order service to calculate loyalty points. And in this case, I'm being even more explicit about the fact that I want the agent to actually follow the quality standards as well, and not just reference pre-think for information, but also look at that code quality and follow it. So I could put this maybe in a shared context file or something, but here I'm just being explicit about it in the prompt. And then you can see right away, it's reading the pre-think context again. It's finding the order service. It's doing some queries. And as soon as it comes up with the queries, it's looking at, a couple different queries. It right away says, wait a second, pre-think context is telling me that this is a God class. I got to be careful with, don't pile branchy logic onto it. So it already knows, hey, I got to be careful about how I'm modifying this code here. So it's making some design decisions around, based on that. So it's saying, hey, we're gonna, push the field heavy access heavy arithmetic into a different entity that's related, and just keep, add like a very thin method to order service so that we're not, overcomplicating it and making the God class smell even worse. So that's how it determined that design choice. Then it's actually making those changes to the code, and it's summarizing all here. So it checks to make sure it works. The tests all pass, and then here it's explaining like, hey, here's what I did. Here's why I designed it this way because of this, these God class metrics. So you can see this is something the agent would not necessarily have figured out on its own if it were just looking at the code, by reading the files and grepping for things. It would probably just have blindly said, great, I'm going to add something else to order service. That's what you told me to do. That's what I'm going to do. But this actually made some more quality decisions based on the context that it had, just like you would hope an experienced developer would do as well. Okay, so back to the deck, and we'll kind of wrap it up and move into any questions that you guys may have. So first of all, just, to reiterate, the nice thing about the code quality, again, as I showed you, is there's the visualizations as well as the sort of raw data in the CSV files. So pre-think, while we think about it as something that's useful for primarily agents, the ability to generate those visualizations is also good for humans as well. So that's a nice thing. And those are code quality visualizations, but you could think about this also for any of the pre-think data that is exported. So you might want a dependency graph or something, and you can generate all of those from the pre-think CSV files that are exported. So finally, to kind of put a finer point on it and wrap this up, I think Patrick took you through kind of why context is a key bottleneck, and how agents end up kind of, in a Groundhog Day, repeating what they need to explore and find out every single time that a new session launches. We talked about how pre-think is able to resolve that once and then feed it to the agent every time it needs it. We also took a look in one of the demos about how it's customizable, it's extensible. You can, it's just a recipe. It's not a black box. It's not we're not stuffing prompts. It's just a program that you can edit and customize and add to and remove things from. So that makes it much more extensible and able to, get the information that is particularly relevant to you. We looked at, how we're actually checking the code in next to, or checking the context in next to the code in the repository. So that's the model that Prethink uses by default. But as I said, they're custom recipes, so there are other possibilities as well, depending on how where you may be looking for context, or where your agents may be configured to look for context. And then finally, I think it's important just to keep reiterating that this is not inference. It's not more inference. We're not having the agent, we're not having the agent run, get some information and output that and store that in context. That's inference, and it can reference that data again potentially, but we don't know if it's complete. We don't know, where it came from, what session it came from. In this case, it's deterministic. It's going to produce the same tables every time. We know it's compiler accurate based on the LST. So we're feeding facts and the right set of facts and a full set of facts to the agent in order for it to make its decisions. And that way, when it makes inferences, it can be reasoning from that set instead of rediscovering it every time. So great, that's our presentation. I think that leaves us about the next 12 or 13 minutes for questions if you all have any.
Yeah, absolutely. That was a great presentation. I love how easy it is to customize with the program. And for our audience, as a reminder, you can submit your questions using the Q&A panel, and we'll get to as many as we can during our time here. So, all right, so Brian, Patrick, let's jump to some of the questions. First question we have here is, how does Prethink stay current as the code base changes? Does someone have to rerun it manually?
Yeah, I'll take that, Patrick. So I think I mentioned it a little bit earlier, but essentially when we saw it was a recipe, and you can certainly run it manually if you'd like. But some of our customers have talked about running it on a schedule, so you can run it either nightly or weekly or however often the code updates. You could potentially choose to run it as part of a CI pipeline, so every time the code changes, it runs it. You could have agents run it before they start up their session. There's lots of different ways, because it's a recipe. It's very flexible, and it allows us to sort of build in each various different ways that they can be updated. So that's the answer there.
And this was like similar, I think, to the second question where I already answered in the chat, but yeah, you can schedule it and then you can use CI to bring it into your yeah. But I think there was another question that I didn't get a chance to answer on the chat. Oh, it's this one. Does the context have to live in flat files in the repo? Could we store it somewhere else, like a database or a vector store?
Yeah, so sorry, go ahead, Patrick.
I think my piece is we got to figure out how the agent can get access to it. When it's not connected to the repo, there may be some, you would need to then build in like some connection, like MCP or an extension. Or Brian, do you agree on that?
Yeah. So, I mean, it depends, to your point, Patrick, depends on what your organization is doing, what you're enabling agents to see. I think we think that this is maybe one of the lowest impact, or I guess I should say lowest friction ways to get data to the agent. But maybe your organization is exploring, central context repositories or things like that, where maybe MCP tools are calling out to those repos. And in that case, it would be easy enough to just write a custom recipe that would take those data tables, and instead of exporting them to CSV, export them somewhere in a central repository. So I don't know that there's a one single way for agents to get context these days. I mean, Patrick, you looked at earlier all the different ways that it can get context. So whatever way works best for you, we just found that checking it right in next to the code has been easiest for us, but there's certainly other possibilities, and the customizability and the extensibility would let us kind of explore all of those.
And even when we check it in right beside the code, it's making sure it reaches for it. So that's where these skills and like instructions come to life. So when you look at different areas like database, vector stores, it's more how will the agent behave to go access the stuff.
Yep, for sure.
That's definitely well said. And with that, we're out of time for questions for today. But for our audience, if you didn't get the questions answered, the Modern team will follow up afterwards. So Brian and Patrick, I just want to just kick it back over to you for any other final thoughts. Also, if you could share with the attendees how they can continue the conversation and also just learn more.
Yeah. Go ahead, Patrick.
I think to learn more, if you go onto our Modern website, there are some pre-think blogs that we have made available. And then, I think final thought is, as you can see, when you provide the right context, you get different output or more efficient output. So it's thinking, how do you provide the right tooling to your agents?
Brian?
Yeah, well said. Yeah, thanks everybody. And it's been good.
Excellent. And also another thank you from all of us here at D-Zone and to everyone who joined us today. And the big reminder is to keep an eye on your inbox for the on-demand recording. Once again, I'm Caleb Kinchlow, and we hope to see you at future D-Zone webinars. Take care.
Thank you.
Yeah, thanks everybody.